Kia ora. We're on page 79. Things get a little bit different. We start having to compare like an actual distribution to a probability modeled distribution. Okay, so the first question is calculate the mean mark. So on the formula sheet, you've actually got a formula for mean. So the mean is mu. It's equal to the expected value of x. Right? An expected value can be found by doing this thing here. I guess we've sort of got to get an understanding of this. This is actually a very poorly written formula, to be honest. This means sum. This is capital sigma. It means the sum of x. So it means the sum of the values, and then this is actually meant to be a dot multiplier, but they've done it like a decimal point because I don't think this had a way to do a dot multiplier. Why don't I just do multiply? I don't know. Right? So it's the summation of all of the points multiplied by their probabilities. Right? This is probability that the distribution takes on value x. Right? So I want to just explain what that means in context of this picture here. So the mark here, so any mark between 10 and 20, we can see that that is 0.01. The probability that a student got a mark between 10 and 20. Now, what is that value x, right? So it's kind of hard because this value x is actually everything between 10 and 20. So with these, generally you've got to average them out. So between 10 and 20, the middle value is 15. Right, so you can go through and do all these 25, 35, 45, 55, 65, 75, 85, 95. The reason we can do that is because we're talking about a mean anyway. So we've essentially taken the mean of each value x, right? So I'm just going to quickly go back to here. Remember, a value x is the point that it takes in the distribution. So this x value would be 2,200. So now these here represent my x's, right? So these are all of the little x's, 15 up to 95. Right, so that's on the picture. These are the little x's. So then the probability that each of these x's is a what place in the random variable is here. See how I've got it here? Probability x takes on that value. Right, so the probability that the value 15 is taken is 0.01. Right, so what we're doing is we're doing a sum. This just means that doing a sum of all of these things of each of those. So it's working out. So we'll do it. So the little x is 15 here. So it's going to be 15 and times the probability that 15 happens. So that's times 0.01. So each of these steps is saying that x times probability x takes value x. Right? It's just each of these, and we're summing it by just doing all of them. We'll add all of these together. So sum, we're just going to put plus. So it's going to be then plus 25 times 0.05 plus 35 times 0.12 plus 45 times 0.18 plus. So see how we're just doing a summation of all of those things. Ooh, shucks. But yeah, it's a little bit monotonous, but if you have a graphics calculator, it becomes a bit faster. If you've got a graphics calculator, or like you don't actually need to write all of this down, you could just go and just type it straight into your calculator. Okay. Plus 65 times 0.19 plus 75 times 0.10 plus while I'm doing this, I might tell you a story about these graphics calculators. This here in this exam is the biggest scam ever that you are one of the big scams you're going to be a part of in your life. Pretty much, if you've got a graphics calculator, and it's going to be a lot easier for you to sit this exam. And the thing is, this is the calculator that does what our NCEA, so Casio's essentially got a monopoly on students doing well in the probability distributions exams. And when you're in teachers college, Casio actually gives every single maths teacher their own one of these Casio graphics calculators, and that's essentially for us to convince you to go out and buy these calculators. The worst part being, whoever writes or designs these level 3 statistics exams, it's pretty much made so that you're going to get a way better mark if you use a graphics calculator. So yeah, let's everyone enjoy me using this beautiful piece of machinery. Realistically, you're probably hardly ever going to use a calculator in real life anymore, because we've got computer programs and internet little things that do a way better job of it. So yeah. Okay, so we're going to just go do an expected value like this. What else was I going to tell you about that? No! What did I do wrong? Syntax error. 15 times that, plus 25 times that, plus 35 times that, plus 45 times that, plus 55 times... Oh, I got an extra decimal point here. 55.4. Does that make sense? That 55.4 is the mean? Yeah, because look at that. The highest point is right there, and that's 55.4, so that's like around about there. And look at that. That one's a bit higher than that one. Yeah, makes sense to me. 55.4. The other way to do these in your graphics calculator is you can go up into Stat, and then you can go and fill these in on lists. So I'm just going to clear all, delete all. Yes. Right, and you can fill out a list. So I can go through and put 15, 25, 35, 45, 55, 65, 75, 85, 95, and then put the probabilities all over here. 0.01, 0.05, 0.12, 0.18, 0.27, 0.19, 0.1, 0.06, 0.02. Now that I've got that all in, I can do a calculate, I think. Yeah, looks pretty good. X bar 55. No, what did I do? Oh no, I've done it wrong. Set 1. That's our 2 of our X list is list 1. Y list is. What the heck? Did I make a mistake calculating? No. 15, 20. What the heck? How am I getting different answers? See that X bar? That should be 55.4. Standard deviation is coming out different as well. Dang it! I wanted to restart the video. I've been talking for so freaking long. Let's see what the answer says. 79. Here we go. 55.4. Dang it, what am I doing wrong on my calculator? So my manual system works. I mean, I'll see what I did wrong with my calculator later on, doesn't matter. Use the graph to find the probability that a student earns 70% or more. So what we do is highlight this. So all we care about is here onwards. Right? So what we could do is we can add up all of these probabilities, right? So the probability of this happening is let's just get the last three probabilities. So it's going to be 0.1 plus 0.06 plus 0.02. 0.18. 0.1 plus 0.06 plus 0.02 equals 0.18. We could write a probability statement. P x greater than 70%. That's like a full way to write it. Use normal distribution to find, ooh, look at that. So that's a model to find the probability that a student earns 70% or more. So I'm going to cheat and I'm going to show you why the calculator is so much better. Or such a big advantage. Put it to variable, so lower is 70 and we want to know everything above 70, so I'm just going to put a really big number. They've told us the standard deviation is 16.5 and we've got a mean mark of 55.4. So then that P x greater than 70% equals 0.1881. You don't need to do anything more, that's enough. Use the same two methods to find the probability that the student earns 40% or less. Okay, so that's this mark here. So that's the first three probabilities. So I'm going to write graph P x less than 40 is going to be 0.01 plus 0.05 plus 0.12 equals 0.18. And then model P x less than 40. Let's go to calculators. I mean, you can just use the table method as well, but I think it's really small number 40. I just wanted to use the calculator to save time. I've already talked too long in this flipping video. 0.1753. What they want you to notice is how similar. See how similar that probability is to this? That's why we model things. Give reasons for and against applying the normal distribution in this situation. Again, M, A, S, S. And then continuous is sort of good as well. Continuous, mostly around mean, mid, mode. Asymptotic and symmetrical. And what was that one again? Shaped like a bell. I'm going to change that one out. Shaped like a bell. Okay. So I just write them down and then I actually do them. Most of the marks are around the mean of 55.4%. So that's a 4. What's another 4? The graph looks fairly symmetrical. Around the mean. shaped like a bell. The data is continuous. The data of test scores is continuous. And then let's do an against. I want an against. I want something that's an against. There are lower and upper bounds. 0% and 100%. So test scores are not asymptotic. There you go. Okay, spent too long on that. Okay, yeah, you can stop the video now, but I'm going to see what I did wrong in this. I want to see what went wrong on my lists. 15, yeah, it looks good. 0.01, 0.05, 0.12, 0.18, 0.27, 0.19, 0.1, 0.06. What the heck? Calculate. No, I don't want to do regression. X bar 55, X bar 55. 2 bar frequency. Ooh, maybe this is what I need to do. My bad. Because, yeah, the reason being, so there's actually 2 variables, right? And the reason I go in here, so I'm doing 2 variables because I've got my X and then my probability. So the X list is list 1. That's where I've got the X. Let's have a look at our summation thing over here. So list 1 is this X, and then actually it's a frequency. I thought that the Y list would automatically work that out, but it doesn't. So I needed to change the second variable's frequency to being list 2, because the frequency of those test scores, the probability, is this value here. So I needed to set my 2 bar for that. So see how that tells you now your X bar, which is so dumb, expected value of X or mean. I think it's because this thing can't do a mu symbol, right? And then this is the summation, and down here we've got our standard deviation, which the thing told us was 16.5. So yeah, this calculator overpowered, but unfair, to be honest. It's unfair that some people get the calculator after this time. Sounds like a dumb system to me.